Today we're going to be talking about reflecting functions across the y-axis and across the x-axis later in this video. So our first one says, let g of x be the indicated transformation of f of x. Write the rule for g of x. And in our last video, if you remember, we talked about write the rule for g of x. It means write the new function for g of x. So our original function, f of x is equal to negative 2/3 x minus 1. And we're going to reflect this across the y-axis. So when we're reflecting across the y-axis, it's our x-coordinate that is changing. And just like in other reflections, so it's always kind of nice to remember that it's the opposite one is changing. If it's the y-axis, we're changing the x-coordinate. If it's the x-axis, the y-coordinate is changing. Now, reflecting across the y-axis changes the direction of the slope by being multiplied by a negative 1, and the y-intercept stays the same. So, multiplying our slope by a negative 1 is the same as multiplying the x value by a negative. And so this function, f of negative x, is equal to our new function, which is going to be g of x. And then we're going to plug in our original function, negative 2/3 x minus 1, into here, this negative x. And so then we get negative 2/3 x minus 1. So we're going to distribute our negative sign. So two negatives are going to make a positive. And so we end up with g of x is equal to 2/3 x minus 1. So this is the rule, our new rule for g of x. And I'm going to graph this so that everyone can get a visual. But unless the directions state that you need to graph it, this would be as far as you'd have to go because we have our rule for g of x. So this is our new function, g of x, and we have our original function, f of x. And I'm going to graph them on this coordinate plane. You guys are probably familiar with y equals mx plus b, well, to graph lines. And this is the same thing. This is the same form that we have right here. And we can just replace g of x or f of x with y. So y equals mx plus b. And m, if you recall, is our slope. And b is our y-intercept. So for our first function, f of x is equal to negative 2/3 x minus 1. Negative 2/3 is going to be our slope, and negative 1 is going to be our y-intercept. I'm going to graph these first. So I put my y-intercept in there, negative 1, and I'm going to, my slope, I'm going to graph 3 points here, and then I'm going to draw a line. And then I'm going to graph my g of x, my new equation, my new function. So 2/3 x minus 1, that's supposed to be a g right there, oops. Our slope is going to be 2/3, and our y-intercept is going to be negative 1. So plot these 3 points here. This is our third one right here. And I'll draw that line. So you can see that our line of reflection is definitely the y-axis, which is good. And the y-intercept didn't change, but the slope is the same, but one's multiplied by a negative 1 and versus the original. So for our second one, we're going to be reflecting a function across the x-axis. I'm going to use the same function, f of x is equal to negative 2/3 x minus 1. And I'm going to reflect it across the x-axis. When we're doing reflections across the x-axis, our y-coordinate is going to be the one that is changing. Well, everything is going to be changing in a reflection across the x-axis, actually. Our slope and our y-intercept will change, but that is because we are multiplying the negative 1 by the y-coordinate. So, on this one, our negative is going to be on the outside, because by the y-coordinate, not just on the x. And so g of x is equal to negative f of x, and we can put this entire function here inside the parentheses, so the entire function will be multiplied by the negative. And then once we have our negative in here, we need to distribute it to both of these, to the negative 2/3 and to the negative 1. Here, two negatives make a positive, and once again, two negatives will make a positive right there. So this would be our g of x, which is this is the rule for g of x, 2/3 x plus 1. And again, I'm going to graph this, and I'm only graphing it to give you a visual of what is happening here. If you were doing an assignment and this is all it told you to do, unless it stated that you need to graph it, this would be your final answer. Got my coordinate plane here, and again, we'll replace the g of x and the f of x both with y. And so for our original function, which we already graphed earlier, I'm going to graph it again. Negative 2/3 will be our slope, and negative 1 will be our y-intercept. I'm going to graph those points quick and draw my line. And then for g of x is equal to 2/3 x plus 1. 2/3 will be our slope, and we will have a y-intercept at a positive 1. And I'm going to graph those points. I'll put my y-intercept there, and then my other two, I will go up 2/3, and then I'll go down to 3 to the left. I'm going to draw my line. Now, if you notice, our y-intercept has changed. They're not the same y-intercept anymore. They meet over here, and it is a reflection across the x-axis. The x-axis here, that is the line of reflection. And so not only did our y-intercept change, but so did our slope. They have two different slopes. For the last one, we're going to do another reflection across the y-axis, but so it says, let g of x be the indicated transformation of f of x. Write the rule for g of x. The linear function defined in the table is what we're going to reflect across the y-axis. So we don't have an original function yet. We don't mean it is. We can get it out of here, but we don't know what it is yet. So there's a couple steps we need to follow. And the first one is going to be write the rule for f of x, to discover the rule for f of x actually, and to write it in slope-intercept form, which we just dealt with back here. See, this is slope-intercept form, y equals mx plus b. And we know our y-intercept, right here it is, because 0, 2, so that one's given to us. And now we need to find the slope of this. And if you recall, so slope is rise over run, and the y-coordinates being our rise, the x-coordinates being our run. If you recall from years past, you can find your slope by taking the y-coordinates of 2 points, so I'll take 2, 0, subtract them from one another, 2 minus 0, and divide it by the corresponding x-coordinate, so 0 minus a negative 1. And we get this, and then 2 over 1, that's supposed to be over there, and that's going to be equal to 2. So our slope is 2, and our y-intercept is 2. So here we have y equals mx plus b, that's our slope-intercept form, and then I'm going to plug the numbers in that I know. I know that m is going to be 2, and I know that b is going to be 2. And then our final step, which is really simple, and I told you earlier that f of x and g of x are interchangeable for y, if that is the correct equation of the function. So that's what our last step is going to be, is to replace f of x with y, or y with f of x, I mean. So now we have our original function. We have f of x. And this is where we started from with all the other problems we've had to do so far. So you guys know the rest of the steps from here. It's just like every other problem. We're going to write the new rule for g of x. And since it's a reflection across the y-axis, which means just our x-coordinate is changing, we are going to multiply g of x by f of negative x. So I'm going to put just my x part, just the x part of my original equation into here to be multiplied by negative 1. And by doing that, I get negative 2x plus 2, because once again, just the x-coordinate is being multiplied by negative 1. And then I just graphed this one just to give you guys a visual. The one in red here, that is our original, f of x, is equal to 2x plus 2. So I got my y-intercept at 2, and then a slope of positive 2. And then the one in purple here is our g of x. And I have my y-intercept at 2 because our y-intercept stayed the same. And then I have my slope of negative 2. Make sure that you guys put both of these equations, recipes into the beginning of your notes, so to fill out that table.